just a little refresher of what we've been doing in this unit. Obviously, there was the review, but starting with the new stuff, we've looked at radicals, square roots and cube roots, and how to find them, how to simplify them, square roots and cube roots, by expressing them as mixed radicals, the relationship between radicals and exponents. Radicals can be changed to fraction exponents, and vice versa. So the last thing we're going to do with exponents are exponent laws. You know all these. These are all from last year. We reviewed them this year. What happens when we multiply two powers? Base stays the same, add the exponents. Divide two powers, base stays the same, subtract the exponents. Raise one power to another power, base stays the same, multiply the exponents. Okay? The same rules apply whether the exponents are fractions or negative numbers. But there's one thing: when we simplify expressions, our final answer cannot have negative exponents in it. If it does, we have to change those negative exponents to positive. And we know how to do that. We flip the base and make the exponent positive. So all I want to do is just go through some questions with you, where we're going to see fraction exponents, we're going to see positive exponents, we're going to see negative exponents, and how to simplify them. So here are some straightforward ones where it's just one exponent law is involved, but remember, your final answers can't have negative exponents. What am I doing to the two powers in A? Multiplying, dividing, or raising one to another? What am I doing to the powers? I'm multiplying. So what happens to the base when I multiply? And what do I do with the exponents? Right, so it will be x to the negative 3 plus 6. Well, what's negative 3 plus 6? 3. Can't be any negative exponents in my final answer. There isn't. Done. What am I doing with these powers in B? Dividing them, which means the base stays the same, and I do what to the exponents? So it's going to be y to the 3 minus 5. And what is 3 subtract 5? Okay, so I can't leave my final answer like that because it has a negative exponent. How do we change it to positive? Take the base and flip it. So what's the flip or the reciprocal of y? No, you haven't flipped it yet. 1 over y. So it's 1 over y to the positive 2. Or 1 squared is 1, so we could have just done this too. Either one of those is correct. Bless you. Just because the base is a number doesn't mean you change the rules. You do not multiply the 7s together. When we multiply powers, the base stays the same. So if the base is, like in these ones, the base were variables. In this one, the base is a number. Still stays the same. Add the exponents. Negative 3 plus negative 4. Which gives me what? 7 to the negative 7. I can't leave my answer like that. I have to write positive exponents. So I get? Right. Or, I mean, 1 to the 7th is just 1. And I'm not going to do 7 to the 7th because that it doesn't tell you to evaluate them. It says simplify. I wouldn't ask you to evaluate. That's a really big number. So I should put or. This one you got to be a little bit careful. When I divide powers, what happens to the base? And what do I do with the exponents? So this is not 2 minus 4. This is 2 subtract negative 4. 2 subtract negative 4, which changes it to plus. So I end up with 3 to the 6th. 3 to the 6th. Be careful with that one. Okay, when you're dividing and it's a negative exponent is involved on the bottom. You could, but you don't have to. I mean, it's good form to do that. You're right. I would have just written it as 2 plus 4 anyway. So, what are we doing here? Multiplying, dividing, or raising one power to another? No, I'm not asking about the exponents. I'm asking about the powers. Raising one power to another. So the base stays the same. And what do we do with the exponents? So 3 times negative 2 gives us an answer of x to the negative 6. I can't leave it like that. 1 over x to the 6th. Or 1 over x in parentheses to the 6th, or 1 over x to the 6th. Either one is correct. This last one, we're raising a power to another power, but the base is a number again. So the base stays the same. Keep the parentheses around the fraction. Because whatever you're doing to the numerator, you got to do the same thing to the denominator. And to show that, we use parentheses. What do we do with the exponents? So negative 3 times 2 gives us 2/5 to the negative 6. I can't leave it like that. 5 over 2, keep those parentheses to the positive 6. Okay. So those are basically some one-step simplifying ones. Yeah, we've still got it. This next one is also a one-step. I'm raising one power to another power. So I get y to the positive 12 because we multiply the exponent. You don't have to write this step if you don't want to. Okay? You can go straight to the final answer. And that is the final answer because there's no negative exponents after I multiply. Okay, now we've got more than one variable. Remember, everything is getting multiplied. Everything. So this is the same as x. I can rearrange the order. This is the same as x to the 3 times x squared times y squared times y to the negative 4. I can multiply these two together. I can multiply these two together. And then I just put those side by side to represent that I'm multiplying them. So when I multiply these two, what do I get? X to the negative 6. When I and times y to the negative 8. Now, there's a little bit of a shortcut we can use when we've got more than one exponent. Because don't write this down, but this is the same as 1 over x to the positive 6 times 1 over y to the positive 8, which is the same as 1 over x to the 6th times 1 over y to the 8th, which is the same as 1 over x to the 6th times y to the 8. Okay, don't write that down, don't write that down, don't write that down. Stop it. I keep going like this. I'm not doing it. There's an easier way to do it. When you've got negative exponents, okay, like this, move the negative exponents down and make it positive. Keep one on top. So I'm going to, negative exponents means make a fraction. This has to move down to become positive. This has to move down to become positive. And then what is up top? 1. It's much quicker than doing all this. Notice I get the exact same answer, except I did it in one step. So if you've got negative exponents up top, you move them down and make them positive. If they're on the bottom, move them up and make them positive. And we'll see some examples like that. So here, remember, this is the same as 10 divide 2 times a to the 5th divide a squared times b to the 3rd divide b to the negative 2nd. So I do each of these divisions and then I reconnect them by multiplication, put them beside each other. So 10 divide 2 gives me times, and I don't have to write the times symbol, a to the 5th divide a squared, a to the 3rd, times, and I don't have to write the times, b to the 3rd divide b to the negative 2nd. B, as in b to the 1st. B to the negative 1st. B to the 5th. Remember, subtract the exponents. 3 subtract negative 2 is the same as 3 plus 2, which is b to the 5th. Oh, Emily, you're so funny. Any negative exponents I have to change? Nope, we're done. Next one. Remember, if there's a variable with no exponent, always assume the exponent is 1. So this is the same as negative 7 times negative 3 times x to the 1st times x to the negative 4th times y to the 1st times y to the 1st. I just rearranged the order because I can do that when everything's getting multiplied. What is negative 7 times negative 3? 21. What is x to the 1st times x to the negative 4th? X to the negative 3. What is y to the 1st times y to the 1st? Sorry? Y squared. Sorry, this should be negative 3. Okay, I've got a negative exponent. This whole thing has to move down. This does not move because there's no negative exponent attached to it. This does not move because there's no negative exponent attached to it. So my answer, the 21 stays up top in the fraction, so does times y squared, but the x to the negative 3rd moves down and becomes positive. It's a quicker way to do it. Because you could have changed this to 1 over x to the 3rd, and then you would have had to multiply them together into a single fraction. It takes more steps. This one, Remember, this is 3 squared times x to the negative 5th squared times y to the 4th squared. I've got to square everything inside and then multiply them together. Well, 3 squared, that's not an exponent law. What is 3 squared? 9. Whoops, forgot the little 2 there. What is x to the negative 5th to the 2nd? X to the negative 10. And what about the last one? Y to the 8th. I'm not done because I've got a negative exponent. What would my final answer look like? Anybody want to take a shot at that? Hala? X to the 10th. Yes. Take the negative exponent in the power, move it down, and make it positive. The final one in this section, well, first thing I can do is I can go take everything inside to the negative 2nd. So because the parentheses means do this to the negative 2nd, do this to the negative 2nd. So I get x to the negative 2nd over y to the negative 2nd. The negative 2nd just doesn't apply to the x. It applies to everything because of the parentheses. Well, now I've got a negative exponent up top, and I've got a negative exponent on the bottom. How do I write this using positive exponents? Well, I got to take this one, and I got to move it down, right? To make it positive. But then I got to take this one on the bottom, and I got to move it up. To make it, yeah. To the first? Yes. So you're doing 1 times negative 2, which is negative 2. Right? Was that your question? Okay, you good? You don't see, you're kind of like, no, I have no clue what's going on. If it's 1 here, that means 1 times negative 2 gives us negative 2. Y to the first to the negative 2, multiply, and I get negative 2. Okay. So I've got to switch both of these to make them positive. So the x moves on the bottom and moves to the bottom and becomes positive. The y moves up top and becomes positive. So notice what we did in all those questions. We did the exponent laws first, and then we changed any negative exponents at the end. Don't change negative exponents at the beginning because it'll get very messy. Do your exponent laws. Any negative exponents move down or up and become positive. All right, let's look at these last 4 on this page. These are ones where there's multiple exponent laws, or 3 of them anyway. First one, don't get thrown by the decimal. Okay? What do I get when I multiply these 2 together? A stays the same. Negative 15. Negative 2. I've got a negative exponent. I have to change it to positive. What does it look like? 1 to the what? What?
No, 0.3. 1 over
1 over 0.3. to the power of 2. Because remember, you just move it down. And if there's nothing left up top after you move negative exponents down, there's a 1 there. Okay, here's a multiple exponent law one. What do you want to do first? I've got multiplying going on up top, and then I've got dividing. Do the multiplying first. Simplify everything up top first here. Simplify everything on the bottom. Divide at the end. Okay? Don't start dividing. There's no rule that says dividing goes ahead of multiplication. So what is 1.4 to the third times 1.4 to the fourth? 1.4 to the seventh. We add the exponents. And we still have to divide 1.4 to the negative second, which gives me
1.4 to the power of 2 over 1.4.
why do you have 2 powers?
No, it's kind of close from, and I realized.
Oh, no. Do your exponent laws first.
Subtract,
No, it's 9 because it's 7 subtract negative 2. It's not 7 subtract 2. It's 7 subtract negative 2, which becomes positive 9, which is a positive exponent, which means we're done. Okay? Okay, this one. What do you want to do first? There's lots, all 3 exponent laws are going on here. Well, yes, but what? Yeah, I would suggest multiply these first. Then let's divide, and then let's raise it to the outside power. So I'm not touching this. Add the exponents. What is 1/3 plus 5/3? 6 over 3. Next, we're going to divide. So I'm going to divide inside. Got to keep the parentheses. Now I have to go 2 over 3 minus 6 over 3. What is 2 over 3 minus 6 over 3? Negative 4 over 3. And I still have to raise that to the 6th. Now, base stays the same. Notice the base always stays as 7. What do I got to do with these two? Don't I have, if I raise one power to another power, don't I have to multiply them? And 6 is the same as 6 over 1. So what is negative 4 over 3 times 6 over 1? Look at your fraction. Negative 8. Always got to simplify fractions. But I'm still not done. Well, move it down, which means 1 is left here. And when you move it down, you make it positive. There's your answer. So it's a little bit crazy. Notice they start getting a little. Okay, this is the last one we're going to do. So I've got a power to a power times a power to another power. What do you want to do first? Yeah, do these first and then multiply after. So let's look at this here. Base stays the same, and if it's a fraction, keep parentheses. Multiply the exponents to get what? -8. I still have to times that by, now let's do this one. Base stays the same. 2 times 3, 6. Now I can multiply these two together. What do I get? Base stays the same. You don't multiply these. Base stays the same when we're multiplying powers. So what's the base? Sorry? That's it? Oh, no. I'm missing something before I move on. Parentheses. You need them. And then add the exponents. -8 plus 6. -2. We got to make this a positive exponent. -2 over 3. Thank you. Now we're good. Okay, that was quite a bit, so that's why I don't want to finish it off. I'll finish it off tomorrow. So what I would like you to do for tomorrow is just, I mean, for next week, I'm going to assign all of exercise 1.7. But just for tomorrow, I would like you to do just the first 2 pages of 1.7. So up to the end of 7C. If you want to go past that, that's fine, because I'm going to assign the rest of it tomorrow for next week.